There we are. Good morning, everyone. So, welcome to the Work From Home edition for 7 Ways to Fail as a Wireless Expert. And we created this Work From Home edition because, well, everyone knows Maslow's hierarchy of needs, and everyone knows already that Wi-Fi is our top priority now, right? You might have seen the version in 2019 that said battery below that. But let's be honest, we now all work from home and we are close to our adapter, so we don't need the battery. But apparently, now the biggest need is toilet paper, which is actually a currency in the world now called Bitcoin. Now this is the work from home edition because home is where the Wi-Fi connects automatically, and that is exactly what we want to achieve today. We're going to help you to make your Wi-Fi network at home work better, work faster, and make sure that you can do your work easier. And we are all working from home. This is a snapshot that I took from a website, Wi-Fi Now. That is on the US. I couldn't find a similar one for EMEA, but I'm pretty sure it will be close to what you see here. This is a snapshot of the biggest cities in the US, and what you see is that from the moment when people were instructed to work from home, immediately the usage from network from home was ramping up as well, and that's the same across the globe. So we're gonna help you to make that network better. So who am I? This is me. This is my Twitter handle. I worked as an end user for a couple of years. I worked for a partner as a field engineer doing Call Manager, Call Manager Express. I worked for a distributor. I'm now with Cisco 10 years. My starting date actually was the 1st of October 2010, which I think is cool because it's 011010. I think that's cool. I'm a CCSI instructor, and in my spare time, I'm a dad, I'm a runner, I'm a cook, I do mountain biking, I do scuba diving, snowboarding, I'm a singer in the ska reggae band, and I'm a Wi-Fi enthusiast. But today, I'm not doing it alone. I actually have Sophia with me.
Hello, ladies and gentlemen. As mentioned, my name is Sophia. I live and work in Russia. Well, I grew up my interest in Wi-Fi since the university time where I got my master's degree in the field of radio electronics and telecommunications. And 5 years ago, I had the great chance in my career to join Cisco with sales program for systems engineers, which took place in Prague, Czech Republic. And since then, I'm working as a systems engineer, serving for customers and partners out there, previously in EMEA and now in Russia. Apart from work, I enjoy doing yoga, going for hiking, snowboarding, and surfing. And as you might guess, I'm a Wi-Fi girl, I'm a Wi-Fi geek. That's why I'm here. So basically with that, I'm handing it over to our next great speaker, Maren.
Hello, my name is Maren, and I actually joined in IT more than 20 years ago when I started to study. And that was in about the same time as Cisco acquired the first wireless company. Then I joined Cisco in 2005 when Cisco happened to acquire the second company focusing on wireless. And today I'm the technical wireless lead for EMER, and I'm helping the country systems engineers, and I also closely work with the BU. I live and work out of Hamburg in Germany, and in my private time I'm also a mom. And this actually made me a home office expert because I figured that working from home is the most efficient way to combine life and work. I love traveling, and on the picture you see me combining traveling and working. I'm actually checking the Wi-Fi here for one of our cruise ship customers. And of course, I love Wi-Fi, and as such, I'm also an access point spotter, which means whenever I walk in a building, I'm trying to find access points.
You are not alone. This is actually the thing that made us in common. We were like, yeah, that's me. So this is what we do. Whenever we enter a building, we look at the ceiling where the access points are installed. And with the passion of Wi-Fi, we created a session called 7 Ways to Fail as a Wireless Expert. This was created for Cisco Live in Berlin, Germany, 2016, actually. And it was a series of best practices on how to do Wi-Fi right, actually. And it was really boring. So I decided, you know what, I'm going to flip it around and I'm going to show how to do it wrong. which makes it funny. And if you understand why it's wrong, then you can do it right as well. And that is where we are today, because we are now looking at the home edition. And we are all working from home, and there's a lot of room for improvement for home networks. And why are we all at home? Well, you can see that 87% of all the companies has completely stopped all travel until further notice, so we don't even know when it's going to happen again. 76% of all companies across the globe said no event participation whatsoever. You cannot meet vendors or partners anymore, and 19% of the companies said there is absolutely no way that you can come to work, to office. So we have to work from home if possible. And well, this is actually, it's one of my favorite series on Netflix, and I think that the episode of Black Mirror that we are in right now is pretty bad. So I hope that this episode will end soon. But when we created this session, basically, I was asking a lot of our colleagues, where did you install your access point? And this is actually one of the pictures that made us realize that we really need this session. Because what you're looking at right now is, first of all, a lot of toilet paper. The second thing that you see is the access point being installed there, which is, as you will see at the end of this session, not the ideal spot to put your access point. So that is the main reason why we created this session, and we're going to help you realize how can you improve your network from home. But to get there, we need to start with the basics of Wi-Fi.
Yes, so wireless has actually been around for quite a few years, and the first standards listed here, .11a and B, have been released in '99, so yes, that was last century. Over the years, the standards have evolved, and the outcome is that we're getting more and more data rates, and that's the improvement that we've got. So, but you're probably missing something on here. So where's the new name? Like the new names? That's Wi-Fi 6. So let us fix that. Makes it a bit easier to read. Actually, those standards were renamed later to make it easier for us to remember. So out of those standards, there's actually two things that have not changed in the past years, and that's the channels that we can use, and that is also the frequency that we are operating in. So what is the frequency? Wi-Fi is using radio waves to carry information in electromagnetic format. And to do this, we are using we're allowed to use two different frequencies. That's the 2.4 gigahertz and the 5 gigahertz. So on 2.4 gigahertz, that actually means in translation, it's 2.4 billion of those waves per second. So that's quite a lot. And even more on 5 gigahertz, it's 5 billion of the waves per second. So this is what we're using to transport. And well, as wireless engineers, we actually like our own social distancing as well. That's the social distancing of channel, and those distances are measured in megahertz, of course.
So one of the questions that we get a lot is Wi-Fi, isn't that bad for health? And I'm no medical expert, but I can answer this question with a common sense. And my first answer is, well, if someone throws that access point at your head at a very hard speed, then yes, it might damage your head, okay? But in reality, let me ask you this question. Who in the audience is using your phone in the morning as your alarm clock? I am pretty sure that a lot of you do this. Is there something wrong with that? No, not at all. I'm doing that as well. But take your phone, take your alarm clock in the morning. You put this next to your head, and your phone actually transmits at 1 watt. That's not that much. I mean, your light bulb is already 30 or 40 or 50 watts. So 1 watt is nothing. But 1 watt actually represents 30 decibels to the milliwatts, which equals 1,000 milliwatts. Again, it's nothing to be afraid of. But let's now have a look at the Wi-Fi access point. We're going to look at a Wi-Fi access point with an RSSI of minus 66 dBm. An RSSI of minus 66 dBm, as you will learn in a couple of minutes, means that you have a very decent connection. That means you are close to the access point, there's no obstructions, and you will have a really decent connection. You can do your video call on this connection for sure. Now, minus 66 dBm actually represents 1/4 millionth of a watt. So you're asking questions about the health impact of that wireless access point. That is 1/4 millionth of a watt of what you have next to your home, next to your head when you're sleeping. So that is something important to realize. The second thing that Maren brought up was the channels. And actually in Wi-Fi, there are 13 non-overlapping channels. Well, there's 13 channels, sorry. 13 channels. And there's only 3 that we can use. That's channel 1, 6, and 11. And the reason for that is because these are the only 3 that are non-overlapping. But as you can see on this picture, they are overlapping. Actually, the only difference is they don't overlap with each other. Now, why is that important? I'm going to take you to my car. This is the radio in my car. Okay, I have a slightly newer one, but it is for understanding. This is the radio in my car. And in the radio in my car, I now have 13 radio channels available. And every radio channel represents one music stream. So there's rock music, there's hip hop, there's dance, there's political talk, there's comedy, and so on. So everyone has their own radio broadcast. And I'm tuning in to channel 7, which is my music, which is hip hop. Okay? But as I told you, there's 13 channels available. They're all overlapping, and all of them broadcast their own channels. So when I'm tuning into channel 7, I actually hear channel 5, 6, 7, 8, and 9. How nice is that sound quality going to be, you think? I'm pretty sure that within 20 seconds you're going to turn off the radio. So what did we agree on? Even though there's 13 channels available, we're only going to broadcast on channel 1, 6, and 11. Okay? And by doing so, if you tune into channel 6, you actually hear channel 6.
All right, so since we're talking about the way to move away from the problem with overlapping channels, we have another Wi-Fi range, which is 5 gigahertz. And the great advantage of it is that it's way wider comparing to 2.4 gigahertz range. That is why we can have way more channels in this case. So for example, if we have a look on the picture on the slide, we have 2 sub-ranges of 5 gigahertz spectrum. And here you can see that we have 19 non-overlapping channels. And it means that actually we can have 19 radio stations without interfering with each other. Another great advantage of 5 gigahertz is that we can finally use channel bonding. And it allows us to combine 2 channels in 20 megahertz and get 40 megahertz, and thus increase the throughput of this channel. Then with 802.11 AC, we were able to get even 80 megahertz channels and with AC wave 2, even 160 megahertz. However, and practically, it's not really good to use 80 or, of course, 160 megahertz channels because, as you can see, there are not so many channels available, and thus it's not really efficient. Also, you're interfering potentially with your neighbor's Wi-Fi. Just for your information, now you can see the frequencies where we have radars working on. So in this case, our access points are checking if with a dynamic frequency selection, if they're working, if there are any radar activity in those channels. If it's detected, then access points switch to radar-free channels. So this is just for your information. However, if you are living away from airport or military station, this is nothing to worry about.
All right. So we're almost through the basics and I'm going to look at some fields, but there are a couple of more terminology that you need to understand. And the first one is the RSSI. The RSSI You already heard me briefly earlier. It's the received signal strength indication. That is how strong is the reception from your client to an infrastructure. So minus 55 dBm or greater, and greater means closer to zero. Minus 55 dBm or greater is exceptional signal strength. That basically means that you're very close to the access point. The access point is visible to you, and the reception is really good. If the minus 67 dBm is still there, you have decent connection. Minus 67 dBm is actually voice-ready network. If the signal is weaker than, actually weaker than 80 dBm, you already are pretty unusable. But minus 85, then definitely you will be dropped off that network, and there's no performance going to happen on that network. So that's the RSSI. And that's actually the number that you see here as well. That's the representation of the RSSI. The second one that is just as important is this signal to noise ratio. So this really means what is your signal and what is the noise floor. And if there's more noise, then the signal will be bad. Even if you are close to an access point, if there's lots of noise, then the signal to noise ratio is not good enough. So if the difference between the signal and the noise is more than 25 decibels, then you have a really healthy connection. If the difference between the noise and the signal is minus 15 decibel, that means that the noise is too high and that you will not have a proper connection. Think about it yourself. You are in an open floor space and there are 50 colleagues around you and everyone is on their phone, okay? Then there's a very high noise level. So then your signal to your customer is going to be bad. Even though if you would be alone, you would have a perfect reception with your customer. That is an example of signal to noise ratio. All right, that was the basics. Time to look at some fails. And we're going to start with the first one that we brought up already, the channels. Channels are really important, and that also applies for your home network. And here you see a great example of what happens when you use the wrong channel. In this case, we see a friendly fellow that parked his car on two parking slots, and that's actually, he's taking out those both parking slots, and both cannot be used. And if you want to understand how this looks like in Wi-Fi, this is actually how that looks like. So you see channel 1, 6, and 11 as wireless channels, and someone put an access point on channel 4. This is actually the same picture, just in Wi-Fi. And for the record, I took this picture in a Cisco building, and yes, this is Cisco UK, actually. So, but it is a couple of years ago, so I'm pretty sure they solved the problem by now. Putting your access point on the wrong channel is actually taking out two parking slots. And, well, this is how it looks like when you have an apartment.
Yes, that's right. So, for example, just to showcase the way Wi-Fi network environments might look like in your case, I would like to invite you to my home to showcase my example. So I live in 14 floor building block, and each and every floor has 4 apartments. And guess what? They all have Wi-Fi. So for example, here I took a screenshot from a Wi-Fi analyzer. And as you can see, I have so many networks out there. Some of them I can hear pretty well with the green SNR, so it means I can hear them very well. And if I change it to a spectrum view in 2.4 gigahertz, it will show up like this. So this is actually a disaster from a Wi-Fi engineer point of view. But honestly speaking, this is so typical picture on a big building block. That is why it's absolutely inefficient to use 2.4. And it's a good idea to check out your spectrum in 5 gigahertz. In my case, it looks way better. There are still a few networks working out there, but since it's way more free, I am using 5 gigahertz and using my Wi-Fi effectively. So basically, this is NetSpot Analyzer. It's free of charge. However, there are so many analyzers out there available. Feel free to check them.
So I use a Wi-Fi analyzer, Wi-Fi Explorer, and this is how it looks like in my house. So this is actually, I'm not living in an apartment. I live in a house in a street, and you're seeing all my neighbors here as well. So we have to understand that we cannot manage the Wi-Fi for the entire building or the entire block. But there are already, just on your own network, things that you can take action on and that you can improve. So this is, again, my own network. So the first recommendation, use standard, non-overlapping channels. As you can see, 1, 6, and 11. And the second thing is, do not use channel bonding on 2.4 gigahertz. So if you use TP-Link, Genius, Linksys, those kind of brands, consumer-grade access points, they have a feature that's called channel bonding or 40 megahertz wide channels in 2.4. Why do they have that? Because it looks great on marketing slides. We can do 600 megabits per second on a 2.4 gigahertz radio. Look at those enterprise vendors, they cannot do that. They can, but they don't, because it doesn't really work. It only works in marketing slides. So 2.4 gigahertz and channel bonding, no. And the last thing that you should do is, if you have a possibility, move to the 5 gigahertz band. All right? So we will see this a couple of minutes later as well. So one of the pushbacks that we get on this is, my internet service provider provides these channel settings. All right, if that is the case, pick up the phone, call the service provider and say, please move my access point to another channel. If you are on channel 4, if you're on channel 7, if you're on channel 9, call the service provider and say, please move the channel, all right? Because you will definitely have better Wi-Fi with that. Think about your neighbors. If possible, agree on channels with your neighbors. If you have issues with your Wi-Fi, I can guarantee you your neighbors have the same problem, because those rules for Wi-Fi apply to every single wireless access point in the world. So in an ideal world situation, this is how your street should look like. 1, 6, and 11, and they should be spread out, and where possible, Wi-Fi 5 gigahertz. So this is how an ideal world situation it should look like. Something to do at home. These are 2 hot links. So they're speedtest.net by Ookla and Speed of Me. So both of them, you can click on them, and I would already recommend you, if you want to do it right now, you can do it. Do it on your phone and do this testing on several spots in your house. Do this testing on several spots, and this is where to look at. So this is a screen dump of what I have right now. As you can see, Zeelandnet, that's where I am right now. The first number should be low. So what you're looking at here is your ping speed. Ideally, it should be single digit. It can be double digit, but then still it should be low. Something below 25, and you're all good with that. If you're above that, that means that maybe you're far away from your access point. There's a lot of interference. Or someone is using high latency applications like Fortnite or FaceTiming. So that is results of that. The second number that you're going to look at is your download speed. And your download speed should be in line with your contract. As you can guess, I have a download contract for 200 megabits per second and an upload contract for 50 megabits per second. And you can see that is well represented in my infrastructure. If this number is way off from your contract, that basically means that someone else is using a lot of your bandwidth, or you have a configuration mismatch on your network, okay? So this is the first test that you can do at home. So the best practice here. Best practices for fail number 1, do performance testing and do them on several spots in your home. Results should be in line with your contract, and if not, you have to change your placement. We're going to look at that soon. From a channel scan perspective, use channel 1, 6, and 11. Only use 20 megahertz wide channels in 2.4. Use free channel in 5 gigahertz if possible, and 40 megahertz is absolutely fine in 5 gigahertz. So my simple rule here is choose a free channel. All right? We're going to look at fail number 2.
Yes, that gets us to fail number 2. So fail number 2 is treating your business Wi-Fi like you treat your home Wi-Fi. So basically, put all your eggs in one basket. So let's assume that's home. So my access point at home, and that's my home wireless network. And then there's myself. and I have a few client devices, such as my laptop, I have a phone, I have an Apple Watch, and maybe some other wireless devices. And then, but I'm not by myself, so maybe there's a partner, and he also has he or she also has a phone, a laptop, and as you've already heard, I also have a kid. He doesn't have a laptop yet, but soon he's going to get one, and I'm sure you have a few kids, some of you, they have a laptop, they have maybe a gaming console, especially now with homeschooling, you need some entertainment as well. And there's a lot of other things at home that are using Wi-Fi you may not realize all the time. So there's a printer, and I have a vacuum cleaner actually. You can use a thermostat to control your heating, and some have lights, they're pretty cool. You can change the color, so and a lot of toys. Then you have an audio system. I actually have one too. So so all of this is in your home, and then. But again, you're not by yourself. So you've seen from Stephen and Sophia that you may also have neighbors that are doing the same thing. So they also have a wireless network which may interfere with yours, and they have plenty of other clients as well. So this is where we're at. And yes, so basically we have a suggestion to solve that.
Exactly. So basically, it would be a good idea to think of different kinds of device groups that you would like to have in your environment, so you can prioritize one over the other. So let's say you have a business critical network that you use for your home office environment, and your partner might use it. So you put only those devices dedicated for such network. Let's call it your SSID. Another network that you might want to have is IoT SSID, where you can put all of your home type of devices like smart TV, audio speakers, lights, and all the other IoT stuff. And the rest could be your kids' SSID, your guests, or any other type of devices that are not applicable for the other groups. So to make it real, just wanted to show you an example. In my case, I have two SSIDs in my house. So first is called Home Office. So this is the one that is used by me and my husband to work. So this is like, let's say, a business critical environment. And this is one that we use for web conferencing, video watching, and all the other business stuff. Also, just to not distract myself and him from work, I decided to block Instagram, Facebook, and Twitter just to focus on work during the working hours. And I also have another SSID, which is called Web Surfer, which is basically the rest, the one that I use for less important applications. And that is why I set the usage limit for that to lower values. So the best practice that I wanted to highlight is think about group of clients that you might want to have in your network. And it could be like in the example that I showed that I showed previously with three different groups. And it should be more than 4 SSIDs just to avoid any kind of management overhead. But basically 4 SSIDs should be enough. And once you do that, we encourage you to take a step further and apply rules and policies to those kind of groups. It could be even layer 7 separation like I did. So you block certain type of applications, either you fully block or you limit the usage of those kind of applications, not to, again, distract yourself for work, or maybe help out to filter certain applications for your kids potentially. So the best practice here and simple rule, prioritize and filter what comes in your network.
And that gets us to fail number 3. So hiding your access point. I mean, as a access point spotter, it's actually quite a hard life sometimes when you go to some homes and try to find an access point. They are really like not to find at all. And people tell us that they find access point ugly, and that's why they hide them. But yeah, what do you do with ugly things? Different options. So there's ugly shoes, I guess. There's, well, cars that may not be as pretty, but you can change them and make them look prettier. Well, that's debatable probably, but nothing wrong to joke about Russian cars because they were actually the first ones that had onboard Wi-Fi.
Yeah, true.
So basically, the suggestion I have is to really make sure that the access point is close where your clients are. And Stephen, you've asked a few colleagues to check where the access points are located, where they have the access points located. So show us what you have.
Yes. So I actually asked our colleagues, where do you have your access point? So all the pictures that I'm going to show you are all Cisco people home access points. So it was very interesting to see the results. So we had people that told us, I have Wi-Fi where my internet service provider connection enters the house. So this is the nice and proper method. So it's installed nicely there, working very well. Someone else had the hang in there method. So yes, it's on the same spot where the connection enters the house, but hanging in there. This is a situation where someone needed stacking on their wireless access points. They just needed to double the capacity. Perfect. This is another example of both spots are from one person. And as you can see, there are two different access points from two different vendors, but with the same SSID. That doesn't work because they are interfering with each other. They do not interact with each other. Roaming is not possible. They are just competing with each other. So even though you have two different access points and you hide them in your apartment, yes, you have coverage throughout your entire apartment, but the roaming doesn't work with two different vendors from two different access points from two different brands. We have people that say, I really care about the workplace the most. So that is where I need the best Wi-Fi. So someone put the access point over there. This is another example where an access point is put next to the printer. It's not ideal, but it works. And especially in that room, you will have definitely the best connection there. This is an example of a wired connection. So we call this a CVO, a Cisco Virtual Office, and it's actually installed over there. And we have colleagues that are on Team Aeronet, so they use the Aeronet access points in their homes, where there's a call out, a shout out on this one that has wireless power over Ethernet. He actually was showing, I have a power over Ethernet switch as well, with no cables connected to it. So this is an example of the Aeronet access point where it's installed, and this is another Aeronet. So we have Team Meraki, so multiple Meraki access points. This one is hiding behind the television, which is not ideal because that means that your radio waves needs to move through the television. So if you put your access point behind your television, that's not ideal. Putting on the ceiling, this is actually my access point. People ask me, where do you have your access point? This is the one that I have in my living room. And as you can see, it's lying down in front of the television, and that's the one that's providing access through the downstairs area. This is an access point where one of my colleagues sent me the message, look, I did this because of the polarization, and I really like that. So polarization is the way the radio waves transfer. I will not go into details there. But what he put here is the access point like it is installed on the ceiling, and he put it on a cardboard box, so he made sure that the polarization is correct. So I like that. We have Team Mix and Match. Mix and match means that you have both Meraki and a traditional Cisco in one setup, working very well, although I wouldn't put the access point over there because, again, that means that your radio waves needs to travel through electrical equipment, which is not the ideal setup. We have Team Linksys, so still a lot of Cisco colleagues are on Linksys equipment. As you can see here, all Linksys, and they're all very happy. It's working flawless. But when you buy a home Wi-Fi router for your enterprise, this is actually what you do. So I see customers that are running Nginx, TP-Link, Yealink, name them, Microtech, where I see it a lot as well. Home Wi-Fi routers for your enterprise. This is really what you do. And you've just seen a lot of pictures of people that use enterprise Wi-Fi in their home, and this is actually what they're doing. So that is the situation. Now you hear me talk about that placement so much, and why am I talking? Why I'm saying this is so important? Well, let me show you why that is important. Okay, this is real. I'm gonna move houses, so I bought a new house, and I'm gonna move houses on the 2nd of August. And one of the questions that I had to ask myself is, where am I gonna install the Wi-Fi? Obviously. So what I did, I took a floor plan and I put in the walls with the right material in there. And this is actually where the internet connection enters the house today. So what a lot of people do is install the Wi-Fi there. That's where the internet connection comes in. Let me show you how that looks like in real. But the first thing you want to realize is, where am I going to work, right? This is the floor plan of the ground floor, and what are my favorite spots going to be where I work? So this is where connection enters the house, and this is the primary spot where I'll be working when I'm working from home and the kids are in school. So this will be my favorite spot, spot number 1. If the kids come home from school, this will be my favorite spot. Spot number 2, I'll be in my office. At night, when the kids are in bed, I'll be on spot number 3, in front of the television, still answering emails and answering requests. And let's be honest, spot number 4, where we are answering emails, is the restroom. Oh, I'm the only one? Okay, sure. So, as we said, this is where the internet enters the house, and this is where most people put their access point. And this is actually how that looks like from a spectrum perspective. So keep in mind, number 1 spot was the kitchen table. I cannot work decently from the kitchen table in this case. The office, I can do so-so. The couch, one couch I'll have decent connection, the other couch I will not. The only spot where I have decent internet will be the restroom. I'll not spend the entire day on the restroom. So we need to do something with the Wi-Fi in this case. So it would be already a lot better if I moved the access point into the living room, right? What you can see here is my favorite spot number 1, decent connection. Spot number 3, decent connection. Spot number 4, so-so connection, but that's fine. It's good enough to answer emails. But in my office, I will not have proper connection. So better would be if I use 2 access points. And with that, you can see that I really have true propagation throughout my entire building. I can even sit in the garden and have decent connection over there.
All right, so in like professional Wi-Fi, we are using specific tools like EcoHouse, iSurvey, and stuff like that. However, for home environment, we could still have good enough tools to test your Wi-Fi and to test the speed and the signal strength in your environment. So one of the examples that I would like to share would be Airport Utility. If you're an iOS user, feel free to use it. It's free of charge, so make sure you enable Wi-Fi scanner in the settings. And after that, you can walk around your house and check out signal strength, which is going to be highlighted as RSSI, showing up that you have a good or bad connection. We mentioned good, bad, and like average RSSI in the beginning of the presentation. So you might want to have fun with AI tools. If you're an Android user, you might want to use Wi-Fi AR, and it's going to work exactly as you can see now on the video. So once you move within the building, you will see the labels with green indicating that everything is okay, showing up RSSI and the speed. If it's like closer to the access point, you will see that the numbers are changing. However, if you're moving away from the access points, the labels are going to be yellow, indicating that something is wrong. So there's also similar to that available for iOS called Airwave. Not so fancy looking, but still good enough to play. So if you'd like, feel free to share those screen recordings with us on Twitter. Would love to see them.
So in a more technical drawing, actually the communication looks like this. So we have an access point. That would be our transmitter in this ideal case. And then we have a receiver, like a smartphone, that would get our messages. So that's like the ideal world. Now, in a real life apartment or office building, there's usually something in between. And something in between actually makes the signal worse. So you can see little numbers at the bottom that kind of explain how much the signal gets worse if something's in between. So when we're at home and we have a wall from different materials, it could be cinder block or a concrete wall or a concrete ceiling, then that will make the signal worse. But at home, we don't only have walls, but we also have other things. And be aware also of metals. So this is actually the typical installation place we find in many places. It's in my apartment actually, where you have a nice electrical office, but it's covered with a metal door. And metal also has a lot of attenuation and makes the signal worse. And the same goes for water. So you probably think that you're not you don't have an aquarium, so you're safe. But well, bad news. People, human beings, are also to 65% percentage from water. So if you have a lot of people in your room, this may actually also make your signal worse. However, let's get back to our building example. So let's assume we're in this house and now there's a wall in between, very likely scenario. Now you can see with the colors that the signal gets worse, and sometimes you may even have two walls in between, depending where your equipment is installed. So the more interference you have, the worse the signal gets. And if we take this to the example of Stephen's new house, the walls and the attenuation of walls is actually the reason that some of the signal looks a bit funny. So when you look at the signal distribution right by the kitchen area, you see the wall. Also, the signal gets significantly worse in the office space if you have a installation like this. And of course, many houses, and I hope that's same for your house, Stephen, don't have just one floor, but they have several floors. I mean, I'm living in an apartment, so I'm kind of safe. But if you have several floors, also keep in mind that especially the ceilings, they're usually in solid concrete. They have a very high attenuation. So if your access point is mounted in the basement and your home office is in the top floor, that's probably not going to work, and you're going to need additional access points to make it working. So my recommendation is that consider positioning an access point like an audio speaker. And in summary, that gets us to the best practice for access point placement. So first of all, make sure that your access point is close to where the clients are. And I guess if you can see the access point, you're pretty safe position. Think of the audio speakers that I've just shown, and if you are in a larger house or apartment, you should definitely consider putting more than one access point for good results. And then also houses are made from different material, so the more you know about the material, then the better you will have an understanding on how the wireless will behave. So if you have a solid brick wall or concrete, then the attenuation will be worse. So really have a thought on the material that's used in your house when you put your access point placements. So in summary, that gets us to the very simple rule: make sure you see the access point, and if you can read the logo, you're probably good to go.
Awesome. So I'm going to talk about interference, and you might think that interference is something business and that is not for you, that you do not have interference. Well, I can guarantee you have interference. And interference has been always around. From the day that communication has been invented, interference has been there. So some challenges that we see with interference. So in an office environment, there's Bluetooth, there's cordless phones, there's mouses, there's audio headsets, but the same goes for your house environment. So here we have your home office, your home network, And actually, you have a microwave oven that's interfering on channel 10, actually. You might have a baby monitor. I'm going to show you that in a minute. Your kid downstairs might be playing with the Xbox or with the PlayStation or the Wii, and they are interfering on your Wi-Fi. And then there's the radar motion sensor. If you are anything within 100 kilometers from an airport, you already might have the radar motion interfering with you. But this could also be a motion detector in your ceiling to take care of your alarm system. They can all interfere with your Wi-Fi. So a typical source of interference, and I'm going to do a quick demo here right now, and it's always challenging to do a live demo while you're talking and see if we have it up and running. What you're looking at right now is real-time live My Network. And I think a lot of you on the call is a parent, so I think most people know what this is. This is actually a baby monitor, and I'm turning it on right now. And look what's happening with the Wi-Fi. So you can actually hear, you hear the echo. That's because I have the audio monitor on right now. And now you can see immediately a huge impact on the Wi-Fi. So you're looking at 2.4 gigahertz, and if one of my neighbors right now was working on 2.4, they are probably complaining that their Zoom video call is having some issues. So this might be very well the case that if you have issues with your Wi-Fi at home, it might be that one of your neighbors is using a baby monitor or is using the microwave oven. And you can see that that has a huge impact. So why am I not having that impact? Because as you can see at the top of my screen, that I'm on the 5 gigahertz band. So even though I'm demoing on 2.4, I am connected on the 5 gigahertz band. So that is what I wanted to share. I'm going to make friends with my neighbors again by turning off the baby monitor and going back to the presentation. So to show you that now it's off, I actually turn it off, and you can see immediately that the air is going solid again, right? You see the red bulbs are gone. All right, back to presentation. We also have demos on other videos and other demos of interference, but for the sake of time, we are going to continue right now. So check if you have known sources of interference like microwave ovens, baby monitors, cameras, motion detectors, Bluetooth, solar panel controllers. I have them on my ceiling. They are interfering on channel 3 and channel 9. Okay, so they are interfering as well. If you have any of these, check what frequency they use and move at least your business Wi-Fi to another channel or band. So the simple rule number 4, have your access point away from sources of interference. So this is not the ideal spot to install your wireless access point. All right? So fail number 5, over to you, Sophia.
All right, so fail number 5 would be underestimating security. And obviously, it shouldn't be the case in home environment as well. So make sure that your Wi-Fi is not protected by default username and password because, well, it obviously gives a key to an intruder, something that they are not out there for your home network. So once you check out wiggle.net, it's publicly available website which monitors Wi-Fi networks out there globally. We can see that around 67% of wireless networks are currently properly protected. So the rest of them are using like even open authentication or deprecated security standards, which is definitely not good. However, since we're monitoring this website for quite a while, we can see that anyway, security is getting better for home environment as well. So, okay, let's think about protecting your network. You anyways need a password. And just to make it a little bit funnier, why not to use your favorite song for this? So if you like Billie Eilish, like me, you can like make up the name or the password. Like You Should See Me in a Crown, or if you like Adele, Rolling in the Deep, We Will Rock You by Queen, you can create a password out like name of the song or of a sentence of the song that you can easily remember. Another way that you can use for protecting your Wi-Fi would be changing DNS settings in your home environment. So we have IP addresses down below, which are formerly known as OpenDNS IP addresses, and now it's called Cisco Umbrella DNS servers, to make sure that all of the DNS requests are going to proven DNS servers, and they're checking if the sources of information are good enough. There are also OpenDNS or Cisco Umbrella offerings available for home environment, which are free of charge, so feel free to use them as well. So, best practices for home environment security. So, WPA2 standard as a minimum for home environment. If you can use .1x, super perfect. We're really, we're really happy for you. So, guest network for sure should be secured, and please don't use deprecated standards like web or open networks. If you're using wireless extenders, please make sure that SSID that they are broadcasting are also protected, because sometimes you can see that there is a main SSID, where is a lock in front of the name, and this name is network is protected, but the other one, which broadcasted by extender, is not. So please don't have that such situation. You can change DNS settings to OpenDNS or Cisco Umbrella, and again, please don't use default username and password. So, okay, yesterday I decided to rename my Wi-Fi and saying hack it if you can, and today it was called challenge accepted. Let's avoid such kind of situation and protect connection in the Wi-Fi.
So making fun with SSIDs is actually really nice. So fail number 6, I know fail number 5, leaving out security is a big fail, but at the same time, we need to have some humor as well. So I want to share some things that you can do with your SSID that could be fun. So be creative with your SSID. Here you see A Pretty Fly for a Wi-Fi, which is a song by Offspring. Head Away, What is Love, Baby Don't Hurt Me No More. That is SSIDs. We see Abraham Linksys. I think that's a hilarious one as well. So this is my home network, and as you can see, I have the Sunflower, so that is my main Wi-Fi network. That is my regular home network where my primary devices connect to. Then we have my CVO network, that's the Blizzard, that is the corporate priority network. I have my QoS optimized network that is optimized for streaming, so all my audio and video endpoints are in there. And then we have the Poop network, which is the kids network. And actually, when they have friends coming over, they're like, look at our Wi-Fi, this is our Wi-Fi, because they think that's hilarious. Obviously, that also has the lowest priority on the network. So if they are watching YouTube, that can never interfere with you and me having this conversation right now. So did you know you can use emojis as SSIDs? Most people didn't know that. Yes, you can. You can actually click on this link and it will bring you to the full list of all emojis that are there. And you can simply select them. I always take the one from the Apple column, select it and copy paste it into the SSID. It looks really cool and you can make really fun things with it. People are really surprised when you show an SSID with emojis. And we already come now to a big downfall on this. It works very good on all Apple devices. It doesn't work on older Android devices, doesn't work on older Windows machines, and if you have a wireless printer, it doesn't work either, and your Roomba vacuum cleaner doesn't support it either. Okay, so that's important to realize. Do not create only one SSID on emojis, because that's not going to work. At the same time, if someone would be doing WAR driving, like they do on wiggle.net, your network doesn't show up, because they cannot pick up the emojis with WAR driving either. So best practices. Use different SSIDs. You've seen it before already, but a maximum of 4. Use some fun with it. And if you do that, you can prioritize them using quality of service. You can use emojis as an SSID. It's possible with some vendors, but not all vendors. And not all Windows and Android machines support it. All right. Simple rule number says, thou shalt have fun. And in the Netherlands, we have a saying that says, life is a party, but you've got to bring your own decoration. And that's the way I see life as well. You got to bring your own decoration. So make some fun. Fail number 7. I don't need to update. Well, why would I say that? Because I have people that say my router from 2007 still works. And then I ask, okay, so what about your phone? When your phone shows that update icon, what do? We hit update. When your app store says there's 3 applications to update, what do? We update. So if you still are using this friendly fellow, don't get me wrong, I absolutely love this one. I'm pretty sure that half of the people in the call right now are like, yeah, I've had that one as well. Yes. I loved it because it was stable, it was fast, and you could run your own Linux distro on it. You could hack it all the way, and it was flawless. But at a certain point, it's time to say goodbye. All right? If you are still on 802.11n networks, which is Wi-Fi 4, you are still living in 2009. Okay, if you're still living in 2009, let me take you back to 2009. 2009, this guy was still alive and he was still a hero. It was not legal yet in Sweden to marry as a gay couple. You could buy Bitcoin for $1. And if you have the possibility, do it. And you're still on this phone. You're on your iPhone 3G or your first Samsung phone. Do you still want to be using that phone? I'm pretty sure the answer is no. And then I still have people that showed me in their pictures they are on 802.11g. That's Wi-Fi 3. If you're still on Wi-Fi 3, you are living in 2003. Let me take you back to 2003. This guy became the governor of California. This guy had his debut playing for Manchester. You could fly in 3 hours from London to New York with the Concorde. And this guy was still a hero. Okay? 2003, it's time to move on. Because today we are on Wi-Fi 6. And we are working from home in Wi-Fi 6. And you need to support Wi-Fi 6. If you buy a new phone today, it's on Wi-Fi 6. So think about your infrastructure to support that. So with that, if you are a Cisco employee, all of them are hot links. If you are a Cisco employee, you can click on the link for order CVO or buy Meraki, and you get into the ordering tool for Cisco employees. If you're a Cisco partner, you can use the not for resale program equipment for your home network as well. If your employer doesn't support that, you can hit the button to go to the Meraki Go link on Amazon. It will give you the direct link on where to buy Meraki Go. If you're a Cisco customer, you can use existing hardware to create an office extent where you have your corporate environment in your home network, and you can already do that on very old equipment. So your 2600 access point that you removed from the ceiling a couple of years ago and still lying around, you can use them to upgrade your infrastructure. If you are on the possibility to use CVO, you can actually use wired connections as well. If you're a non-Cisco customer, welcome to the club. And there's a new portfolio that is just released, that is the Cisco Business Wireless. Those access points look really cool. They're small, and they are as cheap as the Ubiquiti access points. They're in the same price range, and you can manage them up to 25 access points without a controller. So that portfolio is as well available. And if you want to go for the cloud managed portfolio, there's the Meraki Go. All of them are available and entry level from a pricing point perspective. So that's helping you to remove, to upgrade your infrastructure. Because why would you do that? Well, if you're working on the router from your internet service provider, trust me, you'll be happy with benefits of owning your own access point, because then you control your channel settings, your broadcast settings, you can do quality of service, and this really doesn't have to be expensive. I mean, buying a 60, 70 euro access point is already going to bring you so much more benefits than what you have today, because you can put that access point outside of your wiring closet and you can manage it your own. If you are on your own access point, but it's very old, get yourself a recent access point. You will be very happy with it. Better buy yourself two. One for downstairs, one for upstairs. Your employer probably has a program to help you buy or get equipment for your home office. If not, well, maybe it's time to talk about that. So, simple rule number 7, like with your phone, upgrade and update. And with that, that's all, folks. I want to thank you for your time and attention. Maren, Sophia, it was a pleasure to work with you. And thank you very much. That's it.